Well, hello everyone. I am back with another video. This time we'll be learning about, we'll be doing all sort of exercises regarding loops. Now, since we know loops, let me write it down. Now, since we know about loops, everything about loops, right? We know all the definitions, how it works, and all. Now it's time to put all those things into practice and do some problems, solve some problems, so that we can have a better understanding of how loops work, how to think logically, how to solve problems, etc. Now, um, I what I believe is that other than the object oriented programming section, which we will cover later on, the most important section is the intersection of loops, conditionals, variables, constants, whatever we have learned previously. Everything comes into this. Now we'll be solving a lot of examples right now, so I don't think I can cover it in a single video just for your sake, so that you do not feel overwhelmed by this. Because if I try to integrate every problem into the single video, it will take about 5 hours or 6 hours, and it will be a big video, and I don't want you to be overwhelmed by the length of this video. So I'll be covering all the problems in maybe 2 or 3 videos, so that you feel less overwhelmed and you can practice as per your wish. So alright, we'll be starting with the very basics and some of the most basic problems, like for example, uh, sum of n natural numbers, then again product of n natural numbers. So these will be the most basic ones, and then we'll see about AP progression, AP series, GP series, sum of a series, and so on and so forth, right? We'll be learning all of this. After this, after this we'll be learning about factorization, like trying to find the factors of a number. Then we'll be learning prime numbers, how to find if a number is prime or not. After that we'll be writing, we'll be printing prime series, and that's pretty much it that we'll be covering in this video, hopefully, to make sure that it is not a long video and you can practice this. So yeah, I guess we can also cover this one as well, because this is a very small part, which is pattern printing. Now there are a lot of patterns that I am not going over. I'm just showing you the basic patterns, which are kind of interesting ones, and you can try out your own to do some experiment and try printing some patterns. And that's all I'm going to cover in this video. So let's get started. So the first problem that we're going to solve is sum of n natural numbers. So what I mean is that we will go from, let's say I say n as 5. Let's say 5. So what are the first 5 natural numbers? The first 5 natural numbers are 1, 2, 3, 4, and 5. That's what natural number means. So sum of n natural numbers. So n means the number of terms. So there are 5 terms, right? 1, 2, 3, 4, 5. 5 terms. So I want to take the sum of it. 1 plus 2 plus 3 plus 4 plus 5. What does it give you? 1 plus 2, 3, 3 plus 3, 6, 7, and 9, 10, 15. So this gives you 15. So how do we write a loop that does this? It's very basic, right? We can just say, we can start a for loop that goes from, let I will be 1, and it will go till 5, right? It will go till 5, and every time it will be incremented once, and we will have a variable, let's say x or y or whatever. We'll keep on adding the value of I over here, right? That's all. Like for example, let's say x is 0 as of now. We'll actually, let's write a for loop here, not pseudocode. So let's say I say I equals to 1, I less than equals to 5, and I plus plus. Okay, that's all. And then there is a variable. Let's say the previous let's say x is equals to 0 before the loop, you know. And every time this loops, I will say x plus equals to I. And that is basically, obviously, as you already know, that is basically x is equals to x plus I. That's the same thing. So every time we are adding the value of I to x, so x plus is equals to I. So right now value of x is 0 and the value of I is 1. So the loop starts, I is equals to 1, I less than 5, yes, true. It comes in, x plus is equals to I. So the value of I gets added to x. So 0 plus 1. So the value of x now becomes 1. Okay. Then it goes again. Value of I is now 2. Okay. It comes down. What is the value of x now? 1. X plus equals to I. What is the value of I now? 2. 1 plus 2, it becomes 3. The value of I becomes now 3. Right? It comes again. X plus equals to I. So value of I is 3. Value of x is 3. Both gets added. X becomes 6. And now the value of I becomes 4. Like this is the loop. This is one time increment every single time, and the value of I is getting added to x every single time. Okay. So now it again comes down. X plus equals to I. Whatever the value of x plus the value of I. So 6 plus 4, you get 10. Now the value of I becomes 5. That's perfectly alright. Because 5 is less than equals to 5, it will again continue. So x plus equals to I. So the value of x was 10. The value of I was 5. It becomes 15. Now the value of x becomes 6, but it will not go. It will not go here. Why? Because x has to be less than equals to 5. 6 is not equals to less than 5. So the loop will stop. So the ultimate value that you get for x is 15, which is nothing but the sum of first 5 natural numbers. So as you can see, this is 5 because we have selected n as 5. So we can take an input from the user. Let's say whatever the user will give, we don't know. User can give anything, and our loop will run till that point. Whatever the user can give, 10, user can give 100, user can give 500, doesn't matter, right? It doesn't matter. We'll do this. Okay. And of course, you want to see, if you want to see every single time how x is getting incremented, you can try printing all of these. That's perfectly alright. That's your choice. But what we want is the sum of first n natural numbers, whatever the user enters, right? And the exact same thing we'll be doing for this one, the product of n natural numbers. It's the basic same thing. Just remove the plus and you add multiplication. That's the only difference. So now, right now, what will happen? Let me make another column where x and there is I. So initially x is 0, right? And initially I is 1, right? Correct. So x multiplied by I will give you 0, right? I becomes 2. X multiplied by 2 gives you 0. I becomes 3. So anyway, like anything multiplied by 0 will give you 0. So when doing multiplication, we have to set x as not 0, because if we set 0, everything will become 0, right? So we have to make x 1. Yeah. Now we can do our calculation and it will go fine. So x is 1, I is 1. So 1 1s are 1. I becomes 2. 1 2s are 2. I becomes 3. 2 3s are 6. I becomes 4. 6 4s are 24. Right? Yeah. And again, this continues 5. I don't remember the tables, so I don't know. Anyway, it will become 5. 24 into 5, it will give you something, and then x will have some value, and that is the sum of n natural number. Sorry, that is the product of n natural numbers. So we'll do sum and we'll do product. We'll do sum and we'll do product. Okay, we'll do both. So that's the two variation of this thing. Okay, so let's get started with our program. Should I open BlueJ? Yeah, I guess let's open BlueJ then. All right, let's make a new class over here. Class name, let's say some product. This is the name that I can think of. Anyway, some product, we'll open it. Perfect. That's right. We don't need all these things. Let's remove all these things, and again public static void main string args. All right. Always remember to put brackets. The point you start a bracket, immediately close it. You don't need to wait to finish the program. And now hit enter. I mean, not this, not here. I mean, you can do that, but yeah, from middle hit enter. And whatever you are going to write for main, it will come under this. Doesn't look nice. But anyway, so let's start writing the code. Okay. First thing first, we will take input from the user. What is n? What is the value of n? We'll take the input. So whenever we are trying to take input, I don't need these things. So let's remove this. Whenever we are trying to take input from the user, we'll import the scanner class, which can be imported by using import java.util dot star or just scanner, whatever you like. Okay, and just say scanner sc is equals to new scanner system dot in, and that's about it. So here's our object ready, scanner object. Then we can start doing something like this. We'll take the input. Yeah, we'll first do system dot out dot println. We'll ask the user to enter a number. Enter a number, and again do not use ln while taking input. Doesn't look nice. You can use, obviously. It's no syntactical error, but I don't prefer using it. So I'll ask the user to enter a number. Okay, or maybe I'll ask user to enter n, maybe, and I'll have an integer n where we will take the input sc dot next int. Okay, user will give the input here. After that, we'll be starting our loop. For first, let's do the sum of n natural numbers. All right. For immediately close the bracket first. We can write all the things later. Okay, that's it. Close the brackets first, then write the program. You will never have errors, at least regarding brackets. Okay, so let's start writing loops. So for int I is equals to, it will start from 1. I has to be less than equals to whatever the user gives, right? And every time I will be incremented by 1. So for keeping all the values, you need another variable, right? So I'll call this variable as maybe sum, and initially it will be 0 because we are doing sum, right? So that's perfectly all right. Start the loop and start writing the program. Yeah, so let's start. So every time what it will do is that the value of sum, whatever the value of sum there is, I will be added to the value of sum. All right, and just for the sake of understanding, we'll just print the values. Okay, we'll print the values. Every time it gets added, we'll print the values. Okay, so this looks cool. Anyway, after all these things, I'll just say there's no proper alignment, I see. This is a glitch, but I mean that's why I don't prefer using blue jay. So I'll just say system dot out dot println the sum of I put a space, whatever the user enters, n, and natural numbers is, and I'll put the final value of sum, whatever that is, Okay, let's maximize it. This, and we are basically done. We can compile this and see if there are no errors. Yeah, perfect, no errors. So let's run this program. Void main. Yeah, okay. Enter n. So it is asking for it. Let's say I am trying to find the sum of first 5 natural numbers, 1, 3, 6, 10, 15. So the final value is 15, right? The sum of 5 natural numbers. Actually, I'll add sum of first 5 natural numbers. That way it would be good. Anyway, so it starts with 1. 1 plus 2 becomes 3. 3 plus hold on, yeah, 1, 3, 6, 10, 15. Yeah, perfect. Just like what we did here. 1 plus 2 becomes 3. 3 plus 3 becomes 6. 6 plus 4 becomes 10. 10 plus 5 becomes 15, and this is the final value. Just like that. So it is working perfectly fine. And we can omit this, right? There's no need. I mean, you can do some modification over here just to make it look more cool, but there's no need. So that's the first 5 natural numbers. Can we try for something else as well? Let me try. What about this? If I try to run this, let me compile this once again. This is compiled. Let's run this. Perfect. Looks bad, but anyway, enter n. Let's say I want to see for 10. Okay, maybe 100. I don't see anything. Okay, the sum of 100 natural numbers is 5050. I am not printing these things because these things look weird for me, at least. If you want to print, of course, you are most welcome. You can do that. Yeah, let's compile this once again and run this. Maybe enter n. Let's say I am entering 100. So you can see how it is going. It is increasing, right? Sum of first 100 natural numbers is basically 5050. This is the final value, right? You understood what's happening, hopefully. If you have any questions, please comment down below. So now let's move on to our next program, which is basically a variation of this, and I'll write the loop again. I'll just comment this out. Oh, there is no shortcut for commenting on what, I don't know. Let me just comment it out like this. Yeah, perfect. Just now commented out. All right, let me write another loop. So I'll just say int product. Now we'll be doing product. So for product, don't set it to 0 because anything multiplied to 0 will be 0. So there's no point. Set it to 1 actually, and start the loop again for int I equals to 1. I goes till n. Remember that, goes till n. That's why I put equal to. It will go till n, not just before n. Okay, I'll do I plus plus. I'll do this, and I'll say product multiplied equals to I. Whatever the value of I is gets multiplied with product. That's it. and I'll print it for the sake of printing it. System.out.println, and this time I guess I'll write it kind of neatly. I'll first print the value of product. I'll put a star between them. Maybe I'll put this product, and yeah, concatenate all these things. Product into, I mean, I gives you no, I should be doing this over here. Yeah, I'll print this out basically, and I'll actually do this. Whoa, what's happening here? Oh, I forgot to put the bracket. This is, yeah, now it's good. So now I'll say product I. Save this. Oh, I'm still using this variable sum. I need to use product right now. Product. Save this. Compile this. And hey, what's happening? Okay, enter n. So let's say I enter 5 or maybe 6 for that matter. See what's happening. Product is 1, 1 ones are 1. I becomes 2. Our product is still 1, right? 1 2s are 2. Product becomes 2. I becomes 3. 2 3 is 6. 6. So product becomes 6. I becomes 4. 6 4 is 24. Product becomes 24. I becomes 5. 24 5 is 120. 120 is the value of product. I becomes 6. 6. Yeah, alright. 120 into 6 becomes 720. So I'm writing it wrongly. The product of n like n natural numbers is 720. Let me just recompile this. The product of first, I guess, first. Yeah, now this is cool. And now I'll compile this again. I can compile it from here as well. Yeah, it is compiled. Now let's run this, shall we? Run. Yeah. Let's say it's asking for n, right? So what I'll do is maybe I'll put 10. This is what you get. The product of first 10 natural numbers is this. Okay. You got the understand. This is I. The right one is I. 1 2 3 4 5 6 7 8 9. Your loop runs till n. Okay. And this is your product where you are storing the value. So this is the ultimate value that you get. Hopefully it's clear. And now we can obviously push it to boundaries. I mean, we can obviously say something like this. I mean, let me run this once again, and I could say this, and I could say something like this. Let's say n is maybe 1000, maybe 10,000. Will it work? Yeah, I mean, oh, it's not working for some reason. 0. Why? Yeah, I guess some memory issue. Let me run this once again. Okay. It is going to minus because integer cannot handle this value. You remember from data types, right? It cannot handle like there is a certain range, after that it cannot handle. This is going to minus because integer cannot handle whatever comes after multiplying this with 17. It cannot handle that. If I replace integer with long, then I guess it will work. Let me check. That's why you need to understand data types. Those without understanding of data types will not care, but it is what it is, right? So let me do this long. Hopefully, long. No, long is not supported. In C, it's there. Okay, anyway. Now let's compile this. And now let's run this. Okay. And again, let's give it 20. Now do you see that it can handle? Now do you see that it can handle this large number? That's why you need to have a very good understanding of what are integers, what are byte, what are short. That's why, you can't always expect to use integer and get the value. Not always. It won't work actually. There's a range, there's a limit. So that's basically the sum of first n natural numbers, the product of first n natural numbers. After this, we'll be looking into the AP series and the GP series, which are basically kind of very similar to these things with just some modification. So that's about it. So like before directly writing the code, let's understand what is AP series, what is GP series, or in like I mean in general, what is series. Okay, so I'll give you a brief overview. So to understand a series, just hold on. Yeah. So to understand a series, let's see. Let's say I am writing 2, 4, 6, 8, 10, 12, dot. This is an example of series. I'm writing maybe, I guess, this is a series. Okay, I'm writing, let's say, this is a series. So all these are basically series, and like I'm calling this as a series because, see, for in this case, let's say 2 to 4 there is an increment of 2, 4 to 6 there is an increment of 2, 6 to 8 there is an increment of 2, 8 to 10 there is an increment of 2, 10 to 12 there is an increment of 2. Do you see this? 2 to 6, how can we go from 2 to 6? If you see the increment wise it's 4, but then from 6 to 18 it is not. So in this case it's basically multiplied by 3. 2 3s are 6, 6 3s are 18, 18 3s are something. This will continue. Okay, what about this? This is same as like this will be multiplied by, I mean, 1 by 2. Yeah, right? 1 by 2 every time. 1 by 2. Oh, not 2 actually. I mean, it will increment by 2. So basically what I'm saying is that there is a common difference or there is a common ratio. This is called HP. Let's not focus on this. This is beyond our scope. Let's just stay here and understand it. Okay. So now this kind of series where it's all about increment, I mean it is just positive increment, plus 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 plus, it's called arithmetic progression. What do we call it? Arithmetic progression. You will study all these things in mathematics in much more detail. Okay. Then there is GP. GP is basically geometric progression, right? So geometric progression is basically wherever it's all about multiplication. So in both the cases there are three things that you need to understand. Okay, this thing, the first that comes, it is called the first term. I'm taking about AP. Okay, we'll see. um then the next component is this, it's plus 2, right? This plus 2 is called common difference. Common difference. Okay, you need to understand these things. Okay, that's all about it. In geometric progression, this is again called the first term. No change is that first term. And this multiplication thing is called common ratio. Common ratio. Why common ratio? Common ratio because 2 3s are 6, 6 3s are 18. How can you get back? How can you get back? So let's say I divide 18 by 3. What you will get? You will get 6. What if I divide 6 by 3? What I'll get? I get 2. You getting my point? That's why it is called the common ratio. And why it is called the common difference? Because if you want to go back, if you want to go, let's say from 6 I minus 2, I'll get 4. From 4 I minus 2, I'll get 2. You're getting the point. That's what it is about. So now we'll understand how to print AP and GP, and there are obviously there are two ways. There are two ways to do this. The first way is it's like using for loop. Using for loop. The second is without loop. I mean, yeah, without loop actually. All right. Actually, not like that. I mean, you will understand. You will understand what I mean, right? There are two ways of doing it. One is, I'll say, actually this will be the better word. Without formula. With formula. Okay, and you will understand what the formula is. Okay, I'll show you what the formula is. So the first way, let's understand the first way. The first way is basically we'll have a variable. Okay, we'll have our first term. I'll take from user. So from user I'll take three things. The first thing is f. What is the first term? Then the common difference, and the number of terms that you need to print. Let's say in this case the number of terms is 1 2 3 4 5 6, so up to 6. I mean n is 6, right? The common difference is 2. Okay, the first term is also 2. However, there is no necessity that the first term has to be 2. First term can be even 8 as well. I can put 8. Okay, in that case it will go from 8 10 12, something like that. So the first, these three things are the required ones. Okay, now let's take without the formula, how we will do this. So without formula, let's say the user gives you 6, the common difference is maybe 3, and the number of terms is let's say 5. Okay, so how will this look like? This will look like 6 because the first term is 6, difference is 3, so 7 8 9, right? Again difference of 3, so 9 10 11 12 13 14 15 16 17, and we'll stop. Why? Because number of terms is 5, so 1 2 3 4 5, we'll stop. Common difference is 3, that's why plus 3 plus 3, the difference between these things are 3. So this is how the series should look like. Now how we will do using like without the formula, how can we do that? So it's very simple, right? You will have a variable. You will have a variable. Let's take f only. Let's say f is equals to let's for example take f. Okay, f is currently 6. Great. Now what we will do, we'll have a for loop for I is equals to 1 or 0, whatever you like. Yeah, 1 equals to I equals to 0, I less than whatever the guy puts in. Okay, now you can also do something like this. It will like you can do something like this, obviously that's your choice. You can set it to 1, but then you have to put equal to over here. It's the same thing. So basically the loop will go 5 times. That's the main thing. So I is equals to 0, I less than n, and every time I will increment. For every single time, what we will do is that f plus equals to common difference. Common difference. This is without using the formula. This is one way of doing it. Okay, we can do this, obviously, no issues in that. Okay, so if I do this, what will happen every time? Let's say I is 0 at the moment. Okay, so what is the value of d? The value of d is 3. So f plus d becomes 9. Again, okay, I'll keep I as well. I is 0, I is, now I is 1. Okay, I is 1. So f plus equals to d. F was 9, d is 3. It will become 11. Now I is 2. It comes here. F plus equals to d. F was 11 plus 3. Like d is 3. 10, 11, 12, 13, 14. Great. Again, I becomes 4. And it will loop again. F plus equals to d. 14 plus 3, 15, 16, 17. I becomes 5, but it will stop. Why it will stop? Because I have set the condition as I has to be less than n. 5 is not less than 5, so it will stop. N is 5, right? Yeah, so it will stop. So this is what you will get. 6, 9, and every time you will print, right? You will print f as well. So using, like, this is the without using the formula approach. So with formula, this is going to look a bit complex, but it is essentially the same thing. Okay, so I have written the program actually. Let me show you. Actually, you will have to do almost similar thing when doing GP as well. This is AP, arithmetic progression. Okay, not this one, AP series of Java. Yeah, this is the formula that I was talking about. Again, there is a loop. There is a loop, and this is the formula. This is the official formula that you have to understand. A plus equals to I into D. It is what it is, right? It is what it is. So I'll copy this formula. I'll take you with the same example. Okay, so let me just type it down over here. Okay, let's understand this. And there is a for loop again. So let's write a for loop again. Let's see what really happens. So take this for I equals to, I guess the loop again starts from 0. Let me check once again. Yep, 0. Let's go back. Yeah, so again loop starts from 0, loop goes till the less of n, and I plus plus, it happens. So every time this will be printed, like directly printed. Directly print this. So what's essentially happening here? So basically, let's see. Again, let's remove all these things. Okay, and let's start fresh. So the value of I is right now 0. So it will print what? A plus I into D. So first, as per the BODMAS rule, this will happen first, right? So I into D is what? 0 into D. What is D right now? D is 3. So let's do the calculation over here. I into D. I is 0 into D is basically 3. This will be 0. Okay. And 0 plus A. What was A, by the way? Let's say A is 6. I mean, A is the first term. A is the first term. It should be F actually. But anyway, let's say it was 6. Okay. So 0 plus 6, it will give you 6. Does it match? Yes. Perfect. Now I will become 1. When I becomes 1, the same calculation will happen. 6 plus what is I right now? I is 1 multiplied by D is 3. So 1 3 is a 3 plus 6 gives you 9. Does it match? Yes, it does match. What next? I becomes 2, right? So it will be 9 because the current value of not 9 actually, it will be 6 only. It will be 6 only. Yeah, sorry. So a plus 6 plus 2 into 3, right? I value of I is 2 and D is 3. So 2 3 is a 6. 6 plus 6. Oopsie. Did I do some mistake over 10 11? Oh shit. Oh, my bad. It will be 12. 9 10 10 11 12 13 14 15 16 17 18. I'm so sorry. I'm so sorry. Lol. Anyway, the point is 2 3 is 6 6 6 12 will give you that. After that, it will be the value of I will be 3. 6 plus 3 into 3. 3 3 is a 9. 9 plus 6, it will give you 15. Okay. Then again 6 plus 4 into 3. 4 3 is a 12 plus 6 will give you 18. After that, I mean, after 4 it will become 5, but 5 will not go because the value is, I mean, the condition is I has to be less than n. And n is basically 5, I is 5, so I less than 5. This condition fails because I is 5. So the loop will stop. So every time it will give you 6, 9, 12, 15, 18. Are you getting it? So this is the formula that you can use. Like for this is like, this is more efficient. You are not storing it somewhere. You are not doing some calculation and storing it somewhere. It is memory efficient. So you can go both the ways. You can go the first way, which is kind of easier to understand, like add every time and print it, or you can go the second way as well. This is more memory efficient. Anything. So now let's move on to GP. GP is geometric progression, and again we have three things. We have the first term, we have the common ratio, and we have number of terms. Let's say number of terms again 5. Let's say first term be 3, and the ratio would be, let's say, 2. Now what will happen? You need 5 terms. So first term is 3. 3 2s are 6, like 2, right? 6 2s are 6 2s are 12. 12 2s are 24, and dot because I don't know the tables lol. Anyway, this is what you are going to get. Now again, there are two approaches. The first way is without using a formula. The second way is using a formula. So without using a formula, we do something like this. Let's say we'll have like for I will be 0, I has to go less than, I mean, it will go till less than n, I plus plus it will go. Start the loop. Do two things. First things, whatever the value of f is, multiply it with the ratio and print it. End of the story. That's exactly what you're going to do in GP. Nothing different. Let's say the first term is 3 right now, right? Okay, so 3 into, let's say f is 3 into what is value of r right now? Like, yeah, again I is 0 at the moment. What is the value of r right now? R is 2. 3 2s are, it becomes 6. I becomes 1. It will happen again. Now the value of f is 6. So 6 into 2. What will get? You will get, actually no, I mean, this has to be over here. Or else you will start from 6. It will skip 3, right? So just 1 second, I need to just reverse this. In this case, you have to print it like this. You first print f, and then you do the calculation. F multiplied equals to common ratio. Now let's see what happens. So the first thing that you will get is 3. Value of f is 3. The second time I becomes 1. Now, like, yeah, f multiplied by r will give you 6. Then f multiplied by r will give you 6 to the 12. 12 to 24. You getting the point, right? What's happening here? So it's first printing it, then multiplying it, printing it, multiplying it. So that's what is happening. So this is the first way that you can do it. Geometric progression. Every time you multiply things, so 3 to the 6, 6 to the 12, 12 to the 24, and go on, write this like this. Okay. And the second way is, of course, using the formula. So I have written the formula. Let me go back to my code. Where is my GP series? Yeah, this is the formula. Okay, looks kind of scary. That's why if you don't want to use formula, then don't use the formula. It's absolutely no issue. You just need to print it anyway. So I'll go back and I'll paste. What is this? I haven't used the maths library at, like, till now I haven't used the maths library, right? So math.pow is basically using power. I mean, you have learned about exponents in your class, right? So it's basically like, let's say if I say, just to give you an understanding, let's say if I say math.pow 3, 2, this basically means that 3 to the power of 2, which is 3 3s are 9. Are you getting it? It's basically power, 3 to the power of 2. So math.pow stands for power. Okay. So now that you have understanding, let's get started. So this is the formula once again. If you want to print it like this, you are most welcome. You can do that as well. Whatever way you prefer. So we'll get started again. Again, the for loop starts from I equals to 0, I will go less than n, I plus plus, and so on. It will start. Okay. Let's see what it prints. So a is what? A is 3 multiplied by, and I am writing this. You know what this is? This is type conversion. Generally, power gives you this function gives you double. I'm just converting it into int. I mean, you might skip int. That's perfectly fine. But I'm converting it anyway. R power I. What is R at the moment? It's 2. To the power of I. What is the power of I? I mean, what is the value of I? It's 0. 2 to the power of 0. Anything to the power of 0 is 1. So 3 ones are 3. Okay. So this is the first thing that will get printed. Then again, A into I becomes, then I what does I become? I becomes 1. 2 to the power of 1 means the same thing. 3 2 is 6. This is the second term that you get. Okay. So these two are already printed. Then next, 3 into 2 to the power of 2. I becomes 2, right? So 2 2s are 4, 4 3s are 12. You get that, and so on and so forth. It will continue. Okay, it will do. Then after this, it will go 3 into 2 to the power of 3. It will go 3 into 2 to the power of 4, and then it will stop. Then it will stop, because once this becomes 3 4 and it goes to 5, it will stop. Why it will stop? Because the condition is I less than n, and n is 5. It has to be less than 5. 5 is not less than 5. So the condition will stop. So what you will get? You will get 3, 6, 12, and 24, and so on. Okay. So this is all about AP and GP. Hope it's all right for you. And now we'll get into the programming part. We'll finish AP, GP both. Okay. All right. So let's get back to our program. Let's first do AP in both the ways. So I'll write AP series. Okay. Let's get started with the program. You can remove these things. No need. Again, you need to import scanner class, because I am taking input from the user. So import java.util.scanner, and you don't need all of these things. You can just remove this, and public static void main string args. You do this, and you start writing the code. So first things first, you need the scanner object. Scanner sc is equals to sc dot uh, scanner new oops scanner system dot in. Perfect. Then you have an integer that takes to, like, you need three things, right? So int, okay, anyway I'll print these things. Okay, system dot out dot println, enter f, or let's call it a, because as per formula you should call it a. A is the first term, right? I'll also write this first term. Oh, I shouldn't use ln, but this won't look good. So the user will enter a. So let's say int a is equals to, I'll take the input, sc dot next int, take the input. Again, I'll copy paste this. Three things I need. So three things. I need a common difference. I need the number of terms, right? So let's change this. Common difference number of terms. Okay, and we'll call this n. Perfect. So after taking all these input, we can get started. So we'll do it the first way first. For we'll have int I. It will start from 0. I'll be less than whatever the user enters, and every time it will be I plus plus. Oops, yeah, perfect. So I'll write whatever the value of a is, every time it will be plus equals to the common difference. Every time it will be, let's say a is 4 and d is 2, so it will be 4 plus 2 6, 6 plus 2 8, 8 plus 2 10, like this, and every time we'll print it. System dot out dot println, and not ln, actually I'll print it horizontally. So I'll just say, I'll add a little bit of space over here, and I'll put, and every time I'll put a. That's what I'm going to do. And yeah, that's it. That's my program. I'll just compile this. This has compiled, no issues. Let's go back and run this. Okay, so it is asking for enter first term. Let's say first term is maybe 32. The common difference is, let's say 3. Okay, or maybe 4. Yeah, number of terms, let's say I need 10 terms. Okay. Oh, it's skipping. Yeah, it's skipping 32. Okay. I have a bug in program. Like, I'm immediately adding it, right? So it will obviously print 36. So I need to do one change over here. I need to put this just like for GP. I need to, yes, this is correct. It is adding. I mean, as you can see in the program, it is adding perfectly. 36 from 32 to 4, 36. 40, like from 36 to 4, 40, then 40 to 44, 44 to 48. This is adding correctly, but just to show the first one, I just reverse it. I'll first print it and I'll then add it. Okay, so initially it will be 32, right? Then it will be added to 4, added with 4, it will become 36, like that. So compile this, compile, no issues. I'll run this. Great. Okay, it is starting over here only. I think I need to put a system.out.println so that it starts in the next line. Anyway, I'll do it. So the first term is, let's say, 32. Difference is, let's say, 4. Number of terms is, let's say, 10. Now it is printing 32, 36, 40, 44, 48, 52, 56. So difference is 4. So this is how you print AP, arithmetic progression, in the easy way. Okay, in the easy way, without using the formula. Just for the sake of printing, I mean putting a new line, I'll just say system.out.println, put a new line over here. Yeah, okay, that's all. Now let's do it with the formula. Okay, let's comment this out. Okay, this is how you comment /star, and I'll start the comment and I'll end it over here. Whenever you want to end it, put the star first and then put the slash. Yeah, it's commented out. Now if I do it with the formula, I do something like this again. I'll just I don't know, I'm feeling just kind of lazy, so I'll just paste this. Yeah, but this time I'll do it with the formula. So what I'll do is, I'll say system.out.print, like I'm directly printing it, I'm not storing it into any variable or anything. I'll just say a plus, I'm the first term, plus the common ratio, the common difference multiplied by the value of I, just like I showed you, right? And I'll put a space, obviously, just to make it look neat. We compile this, that's compiled, and I'll run this. Yeah, so it is asking me for the first term. Let's say I'll say maybe 34, or let's do something like this. I mean, whatever. Okay, let's do it 32. The common difference is again 4. Number of terms is again 10. Will it give me the same thing? Yes, it is giving me the same thing. So there is absolutely no difference. If you see, you're getting the same thing over here and over here. So there is no difference. It's just the way you are solving the problem. That's definitely up to you how you solve the problem. But I like this approach personally, and you should prefer it this way if you are not sure of the formula, because there is a chance of doing mistakes over here. Just messing up the addition and multiplication will mess up the entire program, right? So yeah, this is all about arithmetic progression. You can do it with the formula. You can try it out. Basically, you can try it out every single time how it is looking like. Try it in a notebook. All right, now since we are done with arithmetic progression, yeah, we can get started with geometric progression as well. Close this, start geometric progression, GP series. Again, I will copy stuff from the AP series because it's essentially the same thing. Let me just open it. Yeah, I'll just copy these things because it's basically the same thing. Copy, and I'll paste this thing, and I have to change this to GP series. Yeah, perfect. And Same thing, just here, not the common difference, I need the common ratio, and I'll rename this D to R. And yeah, I mean, I'll comment this out for now. Again, to comment out, I'll do slash star, and over here as well star slash. Yeah, so first do it with the like without the formula. Okay, let's remove these comments from here, comments from here. All right, every single time it will print first, and it will, yeah, it will multiply every single time, right? So system, yeah, this looks pretty good. Let me put it over here as well, just to put a new line over here. Now looks good. So I just compile this, class compile, no errors. Oh, I'm still doing the AP series, right? Anyways, I need to close it. It's not closing. Yeah, let me GP series, I need to run GP series compile. Anyway, yeah, it is asking for the first term. The first term is, let's say, again, let's say first term is 3, the common ratio is, let's say, 2, and the number of terms is, let's say, 5, and you're getting the exact thing. So how, so what's happening here? 3, the first term, it is getting printed over here. Then 3 2s are 6, 6 2s are 12, 12 2s are 24, 24 2s are 48. You're getting the point, right? So this is basically geometric progression. It is working perfectly fine, no issues at all. So this is how you do it basically. And again, you can do the same thing with the formula. This was without the formula. Every time you are multiplying the value of whatever the value of A with R, which is the common ratio, and just using the maybe formula, I'll just comment this out. Yeah, and this idea sucks. I mean, I don't like it. Anyway, point is, I'll do it with the formula, and I need to change just a few things. It will be, first of all, oh, I need to import the math library because I need to do that stuff, right? So import java.lang.math. That's how you import math library. Once you are done, you do this. Yeah, again, remove this thing. You don't need the comment. Just for the sake of beautification, I'll put this over here as well. Looks nice. Yeah, so anyway, I'll do some changes over here, and that's basically, I'll say math.pow, which is basically power, and every single time I'll do the common difference to the power of I, and the first difference will be like the first term will be multiplied with this thing. Hopefully I'm writing the right program. I'll compile this, no syntax error. GP series start. Enter A. So it is asking for first term, again, let's say 3, the common ratio is 2, number of terms is 5. See, that's, we are getting the same thing. We are getting 3, we are getting 6, we are getting 12, we are getting 24, we are getting 48. That's all right. But do you see there's a point 3.0, 6.0, 2.0? This is the exact reason which I for what I added int over here. I don't want that 0.0 looks bad. I mean, I just need to do int. So this will remove the dot 0 from that. And now this is going to work fine. In fact, what I'll do is this. I'll put this, the entire math thing, into a single bracket. Yeah, now this will look good. I don't want that 0 thing. I'll run the program once again. GP series, or run the program. Let's do the same thing. 3, 2 and 5. See, now you're getting the same thing. 3, 6, 12, 24, 48. So that's how you do it with formula. Again, if you're not sure of the formula, you want to go with the easy way, you are absolutely free to do. Okay, no issues. So now moving on to another series. I want to show you this thing, this particular thing. So we are done with AP series, GP series. Now I'll show you this thing, sum of series. So this is fairly easy. What I say, I already have written a program regarding this. So sum of series is something, let's say I want to calculate, say I want to calculate this series 1 plus 1 by 2 plus 1 by 4 plus 1 by 6 plus 1 by 8 and da 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 da. You getting what I'm saying? So I want to see the sum of this. Obviously I need, depending on the GP and AP, I need all these things. So I have written the program for this. Let me go back. Other series, yeah, perfect. Yeah, like even in this case as well, n to the power of 5. Yes, okay. So let's say I want to find something like this. What do I do? I mean, I'll go back. What do I do for this? So as you can see, this thing is getting increased by 2, 2, 2, right? So let's keep it I mean fixed. So that is, this will always increase by 2. Let's not take any common difference, or let's not take any common ratio for this. Let's say the initial value will be 1, and it will be added by 1 by whatever, 1 by 2, and then it will be multiplied by let's say 1 by 2 plus 2, then we multiplied by 1 by 2 plus 2 plus 2, then 1 by 2 plus 2 plus 2 plus 2. So you're getting it. So it's basically, so what's happening here? Every time it's like incrementing, right? By 2 by 2 by 2. So for this we can write a program definitely. So let's write a for loop, for this. So this is what? This is 4, 6, 8, right? So for this we can write something like this, right? For I'll start I equals to, it has to be 1, okay? It has to be 1. Why it has to be 1? Because look at this. What we are trying to do, what is this basically? Is this 2 into 1, right? What is this? This is 2 into 2, this is 2 into 3, this is 2 into 4, this is 2 into 5. So if I say 5 term, it will go from 1, 2, 3, 4, 5. Now how are we going to do this? We can do this if we start the loop from I is equals to 1. It will go up to I less than equals to n and I plus plus. Okay, I'll do this, and for every single time, what I'll do, I'll say sum plus equals to 1 by 2 into I. That's it. So it will be basically 1 by 2 into 1 plus, the initial value for sum would be 1. Okay, so 1 plus 2 into 1 by 2 into 1 plus, when I becomes 2, let's say I is initially 1, I becomes 2, what will happen then? 1 by 2 into 2, 1 by 2 into 3 when I becomes 3, 1 by 2 into 4 when I becomes 4, and then finally it will stop. Why it will stop? Oh no, it will not stop actually, because it's equal to n. So I will also become 5, and it will be plus 1 by 2 into 5, and all this will be added every single time. It will be added. How? Using this. sum plus equals to 1 by 2 into I. That's all you need to write. And your entire series will be now one thing. Sum cannot be integer. Why? Because you are doing division and stuff. And I mean, what is 1 by 2? 0.5, right? You cannot do integer things. You have to use double and all. So sum is a double variable. Let's write a program for that. Let's go here. Okay, I need another thing. I need another class. Let's create one class. Let's say sum series, because we are taking the sum of a series. Anyways, sum series. I don't need these things. I import java.util.scanner. Remove all these things. I don't need these. Public static void main string args, and that's pretty much it. I want to say scanner sc is equals to new scanner system dot in, and then double sum is equals to, the initial value has to be 1.0, or you can write 1, doesn't matter, it will anyway convert 1.0. So yeah, basically, so you will start the loop over here. Oh, before starting the loop, ask the user how many terms does he want. So I'll say system dot out dot print I'll say enter the number of terms, and the user will enter the terms, or I'll keep it in a variable. Let's say int n. N can be int. I mean, I'm asking for how many terms, 5 or 6. It cannot be 5.2, right? It has to be 5 or 6 or 7, something like that. So I can say sc dot next int, and that's it. I'll take the value. Now I'll say for I, for int I is equals to, it starts from 1, it goes till n. Every time it will be incremented by 1. And now I'll say sum plus equals to 1 by 2 into I, and I'll just okay, for the sake of this, system dot out dot println, just print sum. I'll just add a space over here, and that's pretty much it. Oh, I forgot semicolon. No issues. Save this. This will give me the total sum. Okay, so the total sum will be the last value, right? I'll write system dot out dot print sum of the series is, and then you put the value, right? Put the value over here. Let's say something like this. Sum of the series is sum. I mean the final value of sum, obviously. Save this. Compile this. Run this. So enter the number of terms. Let's say I want 10 maybe. Okay, still not working. I guess I have some bugs in the program. Let me check. Okay. Oh, sorry, I forgot to put the brackets. So what basically this is doing, that 1 by 2 multiplied by I. Without the bracket, what was happening? 1 divided by 2, and then it was multiplied by I. So that is not the case, right? So we have to do it save this, compile this, and I'll try this once again. Let's see if my problem has gone. Okay, I need 10 terms, or still not working. Oh gosh, I need to check what's going on. Okay, so the issue seems that the division is always like it's doing integer division. Integer division basically means that anything after the point will be removed. So I need to make sure that this is double. So there are two ways of doing it. The first one is double. Like I just write it over here. I just compile this. Let me run once again. Hopefully this will return correctly. Check file. Then yeah, now it is giving me the exact values that I want, right? Sum of the series is 2 point. This is the answer that I'm getting. So this is one way. This is one way of doing like making sure that the division is happening in double. Otherwise, if it is happening in integer, then this part that you can see after point that is 4144, this will be removed. If this is removed, then there is no addition, right? I mean, it won't give you the right answer. So that was the issue that was happening. We have resolved the issue. Or you can also do something like this. You can just say this is not 1, this is, let's say I say 1.0. Even this will give you the correct answer. Okay, even this will give you the correct answer. So it's perfectly fine. Let me give a, yeah, perfect. Let's compile this. You can do both the ways. Let me do this. It's asking for numbers over here. Yeah, I say I need 3 terms. So 3 terms. Okay, 1.0, 1.5, 1.5. So basically the final answer is 1.91666667. Okay, perfect. So it's working as expected. No issues. So this is all about the series. We have understood AP, we have understood GP, we have also understood how to find the sum of any series. So that's all about series. All right, guys. So the other topics that are factorization, finding factors, prime series, pattern printing, which is, yeah, I mean, these topics I think it's best to cover in the next video. I don't think I'll make 2 videos. In fact, I'll make 3 videos, because the current video is already like it's more than 1 hour. So I don't want you to get overwhelmed about it. That's why I will stop the video right here. So we have covered sum of n natural numbers, product of n natural numbers, arithmetic progression series, geometric progression series, sum of series, all these things, right? So that's about the video. In this video we have covered all about series and other things, printing. And the next video will be covering factorization, prime numbers, we'll be covering prime series, we'll be covering pattern printing. That will be the next video. And in the video after that, we'll cover different solved examples using loops, which is going to be kind of a little bit advanced or intermediate, you can say. So that's it for this video, guys. See you in the next video. Bye bye.